Hello class, welcome to lesson 8.5, which is all about difference of squares and perfect squares. By the end of this lesson, you should be able to factor binomials that are the difference of squares and use difference of squares to solve equations. And you should be able to factor perfect squares, trinomials, and solve equations involving perfect squares. So first, let's talk about difference of squares. These usually are students' favorite problems to factor because they tend to be, once you get the pattern, the easiest. So it's when you have something squared minus something squared. So an example, if I had x squared minus 25, I could write that. X squared is just an x and an x, and then negative 25 is just 5 times a negative 5. So my answer is x minus 5 times x plus 5, or you could write it the other way, x plus 5 times x minus 5. Same thing, t squared, that's just a t times t, and then negative 64, that's just a positive 8 minus 8. So once you realize that if you have something squared minus something squared, you can just split it up into whatever those two squares are. One thing to note, this only works with subtraction. If you had t squared plus 64, that does not equal t minus 8 times t plus 8. And it also does not equal t plus 8 times t plus 8. Okay, so we'll talk more about addition later. But difference of squares, this trick only works when it is subtraction. So let's start right away. We have letter A, we want to factor. We have 81 minus c squared. 81 breaks up into a 9. And then minus c squared, that's a minus c plus c. And that's it. My answer is done. 64g squared minus h squared. 64 breaks up into an 8 and an 8. And g squared breaks up into a g and a g. So it's going to be 8g at both of those. And then I have a plus h minus h. C, 9x cubed minus 4x. Notice how they have something in common first. You might have seen this cubed and been like, I don't know what to do about that. Take a breath. Look, do they have anything in common? Factor out the thing they have in common. So I have x, and then I have 9x squared minus 4. 9x squared minus 4 falls into that difference of squares pattern. So I keep my x, and then I say 3x minus 2 and 3x plus 2. And now this whole thing becomes my answer. Oops. If you have a term that is negative, a first term that is negative like we have right here, what I want you to do is pull a negative out. But then also, look, we have a y cubed. I'm going to pull a y out because I have a y in each term. I'm left with positive 4y squared then. And then this plus becomes a minus because I pulled this negative out, 9. So then I have negative y. And then how do I get 4y squared? I have 2y and 2y. And then I would have plus 3 and a minus 3. And again, that whole thing is my answer. Don't forget to carry down the thing that you pull out. What happens if you have something where it can be factored more than once? Because that will happen. So let's look at an example like that. This is the difference of squares, right? I could write this as y squared plus 1 and y squared minus 1. And then if I look, this is also a difference of squares. So I can break it down even more, and I can keep my y squared plus 1, and then my y squared minus 1 becomes y plus 1, y minus 1. So that whole thing becomes my answer. I had to apply it twice. Remember, if you have addition between two squares, it doesn't break down anymore. All right, now if I look at this next one, I have 4 a to the 4th minus b to the 4th. Okay, so that 4 is a perfect square. That would be a 2. And then to get a to the fourth, I would have a squared here, a squared here. Then I'm going to have a plus b squared and a minus b squared. Now looking at this, okay, there's the plus one, so I'm going to ignore it. But if I look here at the 2a squared minus b squared, the a squared minus b squared would break down, but the fact that there's a 2 there, and 2 isn't a perfect square, meaning there's not a number times itself that gets us 2, I'm actually done. I can't break that one down anymore. So that one is complete because there's no number times itself that gets me 2. Letter C, if I look, I have 81 minus x to the fourth. That would be a 9 plus x squared and a 9 minus x squared. Again, once you have the addition, you can't do anything else to it, so I just carry it down. And then 9 minus x squared is going to break up into 3 minus x and 3 plus x. All right, what if I give you a problem and I don't really tell you what technique to use? The first step is always going to be, do they have something in common? Always pull out the GCF. That was the first section of this chapter. So in this one, they have a 2 in common, so I'm going to pull a 2 out. And then I would have y to the fourth minus 25. If I look at that, hey, y to the fourth minus 25 is a difference of squares. So I can say 2 times y squared minus 5 and y squared plus 5. Now, 5 isn't a perfect square either, so I know I am done. I can't break that up anymore. Don't forget to write the number that you pull out. That's one of the most common errors I see from students. Okay, then if we look at the letter B, we have 6x to the fourth minus 96. If I pull out 6x to the fourth, or actually, I can pull out a 6, sorry. I cannot pull out an x to the fourth. But if I pull out a 6, I am left with x to the fourth minus 16. And then I would have 6x squared plus 4 and x squared minus 4. And I see, okay, this one's addition. I can't do anything with that. So I carry down the number I pulled out. I carry down my x squared plus 4. But then x squared minus 4 breaks down into x minus 2, x plus 2. So you can see it's possible to have lots and lots of factored terms. There we have 4. We have 4 different things pulled out. So that will happen in some of your problems. All right, now if we look at trying to solve an equation for this, what are the solutions of 18x cubed equals 50x? I'm going to subtract that 50x over so that way we equal 0 because that's what we always want our equations to equal when we are factoring. Okay, so these both have a 2 in common and they have an x in common. So if I pull out a 2x, I'm left with 9x squared minus 25 equals 0. So then I'd have 2x, and then I have a difference of squares there. So it becomes a 3x minus 5, 3x plus 5 equals 0. So then in order to solve this equation, I'm going to say 2x equals 0. Then I take my first parentheses, 3x minus 5 equals 0, and then a 3x plus 5 equals 0. And I solve each of those. So 2x equals 0, divide both sides by 2, x equals 0. That's my first answer. For this next one, add 5 to both sides, divide both sides by 3. That's my answer. This time, subtract 5 to both sides, divide both sides by 3. And there's my answer for that one. So I have 3 different answers, and they match letter H if I was trying to go off of the answers they gave us. So that's how you would solve that. You need to completely factor it, set each factored term equal to 0, and solve. All right, so that was all about difference of squares. Now let's talk about perfect square trinomials. So perfect square trinomials are when you still have that a squared and b squared, but the difference is you have a middle term, okay? So that middle term always equals to 2 times a times b. 2 times a times b. And then the way that you write it at the end is really nice. It's just a plus b quantity squared or a minus b quantity squared. So if we look at this first example, x squared plus 8x equals 16. My number in front of the x would be a 1, right? So I'd have a 1. The square, the way that I get to 16 is 4. So for this middle term, I would check, is 1 times 4 times 2 equal to 8? Yes, it is. So I know I have a 1x plus 4 times a 1x plus 4. Or, the way that I prefer you to write it, x plus 4 quantity squared. Then here I have 1x squared minus 6x plus 9. So I have 1 there. In order to get to 9, I would multiply 3 times 3. So I check, is 1 times 3 times 2 equal to 6? It is. So I know that I'm going to have a 1x and a 3. And since this is a subtraction in front of the 6x, I'm going to use subtraction as my symbol. Just like since this one was addition, I used addition. So then I have x minus 3 quantity squared. All right, so then example 5, let's determine whether each trinomial is a perfect square trinomial, right, yes or no. If it is, we want to factor it. So if we look at that first one, let's test it just like I did on the last slide. Let's see, in order to get in order to get 9y squared, I would have a 3 in order to get to that 9. In order to get 16, I would do 4 times 4. So is 3 times 4 times 2 equal to 24? Well, 3 times 4 is 12. 12 times 2 is 24. So I know that this follows the perfect square trinomial. So the way that I write it is I had a 3y, because I need that y squared, and then I have plus 4 squared, and I'm done. The reason I know that was plus was because my first symbol was plus. Okay, this one tends to be a little trickier than difference of squares. If you don't feel comfortable with this method, you can always do the box method. That's totally fine. You'll get the same answer. All right, then if we look at the second one, 2a squared plus 10a plus 25. First of all, 2 isn't a perfect square. There's no number that I could multiply by itself to get to 2. But a common mistake I would see people do is they would say that this was a 2, this was a 5, and they would say 2 times 5 times 2, and even then, that doesn't equal 10. So what you're going to do is say this is not a perfect square trinomial. Okay. Now, we have another example. We want to factor this one completely. So this time, I'm not giving you any directions on how to solve this one. I want you to see if you can solve this one on your own. Good luck.
Hi, everybody. Jesus loves you. It's Miss Chelsea's birthday.
And then we have a difference of squares there, so I can say 2 times x minus 4 and x plus 4. And that is our final answer there. If you're unsure of how to get there and you want more direction, please be sure to reach out for some help. Let's do our last example, which is solving equations. And so let's start with the first one. We have a squared plus 12a plus 36. I see I have a 1 here. This would be a 6. So is 1 times 6 times 2 12? It is. So I know I have a perfect square here. So I would say a plus 6 squared equals 0. And then to solve that, you take everything inside your parentheses. So a plus 6, set it equal to 0. So a equals negative 6. And that is your answer. Okay. If you wanted to do the box method, you would say, what are factors of 36? It's 1, 36, 2, 18, 3 and 12, 4 and 9, or 6 and 6. and then it would have to add to 12a. So you would end up having a 6a and a 6a, and then they would have an a in common, left with an a, left with a 6, left with a 6. And so that's how you would see that we have a plus 6 times a plus 6, or a plus 6 squared, right? Because that's the same thing as what we just wrote. Okay, now let's look at the next one. Actually, why don't you guys go ahead and try to solve this one on your own? Good luck. All right, hopefully for this one you ended up at x equals -9/2. If that's not where you ended up, please be sure to check the work and then also reach out for some help, okay? I'm more than happy to assist you. And actually, this should say example 8. My bad. This is the very last example, I promise. You can even see page 11 of 11. All right, this last one. We have the quantity of a minus 10 squared equals 121. This is a little different than the last slide because when we got to this point, it usually equaled 0. So the way that you solve this, so if we think about how we solve equations, addition undoes subtraction, subtraction undoes addition, multiplication undoes division, or division undoes multiplication. So a square, the opposite of a square is a square root. So what we do is we take the square root of both sides and they cancel. So then I have a minus 10 equals the square root of 121. But something important to know is because it's a square root, I have to write plus or minus in front of it. I'll explain why in just a minute. What is the square root of 121? It is 11. Now, if I were to say what is 11 squared, you guys would tell me, hey, that's 121. If I said what's negative 11 squared, hopefully you would tell me it's 121 because a negative times a negative is positive. So because of that, you see we could use the positive version or the negative version of the number 11 to get 121. So that's why we have to do plus or minus. So then when we solve, we have to move that 10 over, and I'm going to say a equals 10 plus or minus 11. And what that does is it breaks it up into two different equations, 10 plus 11 and 10 minus 11. So 10 plus 11 gives me 21, 10 minus 11 is negative 1, and those are our two answers. Now if we look at this next problem, I would start out by doing the square root of z plus 3 squared equals the square root of 26, plus or minus. My squared and square root cancel, so I'm left with z plus 3 equals plus or minus the square root of 26. Z equals negative 3 plus or minus the square root of 26. Split it up into two problems, negative 3 plus the square root of 26, negative 3 minus the square root of 26. If I plug that into my calculator, I get 2.099 for this one, and I would get negative 8.099 for this problem. Okay, so that was the absolute last one for this assignment, or this video, I should say. If you have questions, I realize this was a lot of information, please feel free to reach out for help. I highly encourage it, and I hope you guys have a great day.